All right.
No, but like seriously, what's the difference in somebody there? They have black hair.
All right, are you ready? Let's do it. Okay, today is like 3 kind of random topics, but they're all pretty easy, so they're on the same day. Did you drop credit? Okay. Welcome. All right. So your graph is a function. We covered this last time. Okay, if in a table your x's can't repeat. Okay, and then if it's a graph, it has to pass the vertical line test. So will you just draw me a U this way and a U this way? Which one would pass? The U or the C? The U would pass. This is a function. And then I'm going to put a little check for pass BLT. Okay, versus the C, when you kind of flip the U on the side, okay, that is considered not to be a function. And the reason why is because it fails the vertical line test. Okay. And then if you want to draw yourself a little line, okay, it would cross it twice. That's the problem. Okay. So you should already know that from last class. Then remember last time we did inverses. Okay, so the next feature of a graph, besides whether it's not a function, is whether or not it's one-to-one. Okay, so for a one-to-one, it has to have x's can't repeat and your y's can't repeat. So for a function, you only care about x's, but for a one-to-one function, okay, your y's can't repeat either. Okay, and then not only does it have to pass the vertical line test, but it's going to have to pass the horizontal line test. Now, if your function is one-to-one, you might be wondering why that's even a thing. Okay, is that one-to-one functions, both the original and the inverse are both functions. So if you let the y's not repeat, then when you switch the x and y's like we did last class, the function's still good. Okay, or if it passes the horizontal line test, then when you flip it, you know it's going to pass the vertical line test. Okay, so one-to-one, both of these have to be true. Okay, so there are a couple ways that you should be able to do this. The first one is from these little sets. Okay, so look at the first one. Do any of your x's repeat? Yes or no? These are the x's, these are the y's, in case you don't know how to read these. Okay, so all the x's are different. All the y's are different. So then this is one-to-one. Okay, and what that means is none of your x's, none of your y's repeat. Now look at the second chart. These are my x's. These are my y's. Do any of my x's repeat? Okay, just look at x's first. 2 and -2 count as different numbers. Yeah. So all these are different. So it is a function, but it's not one-to-one. Here's why. I have 2 different numbers that are both mapping to 4. That means that 4 is an answer twice. That counts as a repeat. Okay, so I want you to put here, your x's are good, that it's a function, but it's not considered one-to-one. Okay? And then for that first one that we wrote, I'm going to add one-to-one function. That way you can tell that it's both. Okay? Now look at the third one. Remember, first circle are your x's. Second circle are your y's. Do any of my x's repeat? Okay, it would be yes. These are kind of weird to read, but remember, 4 goes with how many partners? 2 different numbers. It goes with 2, and then 4 goes again with -2. So that does count as a repeat. That would be not a function. Okay, not a function. And if it's not a function, then it definitely can't be one-to-one. Because one-to-one, you're actually adding extra criteria to it. Okay, then just to help you out with this, let's write this as a table. So 4 goes with 2, and 4 goes with -2. And then 9 goes with 3. So it is a little bit easier to see it if it's written as a table, but for the circles, basically if you have any like arrows coming out of the same number twice, that means it's a repeat. If they're both going to the same number twice, let's write the same thing for this one. It would be 2 with 4 and -2 with 4. Okay, so there's your repeat, there's your repeat. Okay. So if you have a table, you're looking for those repeats. Okay, for the bottom two, we want to do graphs. Now, we've already kind of talked about these shapes, but what is an x squared shape here? Okay, I'll give you options. Is it a V, a line, a U, a hook, a squiggle? U, and what does the +5 do? Up, very good. So go 1, 2, 3, 4, 5, and then just sketch yourself a little U here. Okay, the first question I want you to ask is if it passes the vertical line test. So I'm going to put VLT. Okay, then I want you to think about if it would pass. Now remember, vertical lines, when you draw those slices in, it can only touch once. So I draw in all my lines here. Are they ever going to cross through it more than once? No, then it passes. So it is a function. Now we're going to check the horizontal line test. And instead of me slicing it up and down, I'm going to slice it side to side, but the rule's the same. It can only cross once. Is it going to pass or fail the horizontal line test? Fail. Fail. When I draw my line in here, I see that it would cross twice. So put an X there. So it passes the vertical line test. That means that it is a function, but it is not one-to-one. Okay, so to be a function, it only has to pass the VLT, but for one-to-one, it has to pass both. Okay, let's do the next one. Okay, we have covered an x cubed graph. So let me list the choices and see if you remember. A line, a U, a V, a hook, or a squiggle. It is a squiggle, good. Now the negative is going to make it flip, and the 4 is going to shift it up. So go ahead and go up 4, and then you're going to draw yourself a downhill squiggle. So it should look like this. Okay. You could also, though, type that into the calculator if you weren't sure. Will it pass the VLT? Yes. Will it pass the HLT? Yes. Yes, then not only is it one-to-one, but it's a function and it's one-to-one. Okay, so that's the first thing that you should be able to do is identify whether it's a function and then also whether it's one-to-one. Okay, turn the page when you're ready. The next feature that we're going to talk about is whether or not functions are commutable. So on the next, or sorry, commutative. So go ahead and turn the page. Okay, the commutative property says that you can reverse the order and that you would get the exact same answer. So for commutative, I want you to write down 3 plus 5 equals 5 plus 3. Okay, the order that I add them in does not matter. That's what commutative means, okay? So functions are considered commutative if when you do f of g, you get the same thing as if you did g of f. Okay? And then if you don't remember what this means, I think we covered it last week, but it's where you would plug G into F, and then I would plug F into G, and I would see if my answers come out the same. So let's do it with this first set of equations. Okay, first, we're going to do F of G. Then we're gonna do G of F. And then we're gonna see if they come out the same. If they do, it's commutative. If they come out different, it's not commutative. Okay, so let's do this one first. I want to take the G formula and plug it into F. What is the F equation? 3x minus 4, then it's 3 blank minus 4. And then I'm going to put the G of X equation into that spot. So now it's going to be a third x plus 4. What is going to happen when I have a times 3 and a 1/3, which is really a divide by 3? Cancel out. Then I have x plus 4 minus 4. What happens next? Cancel out, and all I'm left with is an x. Okay, let's check on the other side. Now we're doing reverse order, that rather than starting with the 3x minus 4, I'm going to start with the 1/3 x plus 4. I'm going to leave a blank where the x is, and then I'm going to put that equation into this one. So my G of X equation is a third parentheses x plus 4. But notice that where the x was, I'm leaving a blank because I'm going to slide the f function inside it. What's my f formula? 3x minus 4. What happens with the minus 4 and the plus 4? Cancel out. Then all I'm left with is a third of a 3x, but then a divide by 3 and a times by 3 are going to do what? Cancel out. And all you're left with is an x. Then is it commutative? Yes, because they came out to be exactly the same on both sides. So this would be yes, commutative. Okay. Now, last class, we talked about inverses. Okay, just to jog your memory, remember we just switched the x and the y and then resolved. Commutatives should always, inverses should always be commutative, is what I meant to say. So right here, this means that all inverse functions are also commutative. And what that means is that no matter which one you start with, you should get the same thing either way. So will you take a look at number 2? Let me show you why it's commutative. Remember, we talked about this little pattern last time. A minus 1 on the outside turned into a plus 1 on the inside. Do we remember that pattern? We had a times 2 on the outside turned into a divide by 2 on the inside. So remember, that pattern should always be true for inverses. So what's going to happen is all that crap is going to cross out, and it's going to also make it commutative. So let's do it. We're going to start with this one. 2x cubed minus 1. Notice I'm leaving a blank where the x is. And then in the blank, I'm going to plug the other equation into that spot. So this guy is going to go into that blank. Then from there, you're just going to check the math on it to confirm that both sides come out the same. So what's going to happen with a cubic root and a cubic power? Cancel out. Then I have a times 2 and a divide by 2. What's going to happen? Cancel out. Then I have a plus 1 and a minus 1. What's going to happen? Cancel out, and you just get an x. Very good. Now, if we do the other side, we should get the exact same thing because they're inverses. So I'm going to start with this formula, but I'm going to leave a blank where the x is, and then I'm going to plug this one into that spot. So big cubic root, x plus 1 over 2. And then in that blank where the x was, I'm going to plug my 2x cubed minus 1. And then basically just everything should cross out. So let's see if it does. Minus 1 plus 1, what happens? Okay, then I have a times 2 and a divide by 2. And then I have a cube and a cubic root. Cancel out, leaves you with just an x. So I will spare you doing another one that should always happen. If they're inverses, they're automatically commutative. And it's because of that pattern that we talked about last time that everything just ends up replicating itself and crossing. Okay, you can do number 3 for fun if you want. Okay, go ahead and turn the page. I think we only have one thing left. Great. Okay, the last thing that you have to know how to do today is determine whether a function is even or odd degree. So an even degree would be when your ends do the same thing. So do you see on this first graph that both ends point up? And on this graph, both ends point down. Okay, and then on this graph, both ends kind of fan out. Okay, these are all considered even degree functions. Okay, now even degree and even aren't exactly the same thing. Even degree, your ends just have to do the same. Okay, but for it to be truly even, the y-axis has to cut your graph in half and give you symmetry. So all of these graphs are both even and even degree. Okay, odd. Your ends should do the opposite thing. So I have one end up, one end down. That's odd. Okay, this one we have one end up, one end down. Okay, one end up, one end down. Okay, another feature for an odd graph, not odd degree, but truly odd, is that if you spin it 180 degrees, it should be symmetric. Okay, so that's called symmetry about the origin, but I want you to write a 180 degree rotation. So for example, look just at the line. Okay, look at this line right here. Put your finger on the origin and then spin your paper upside down. You see how it looks exactly the same as it already looked? And then I can spin it back and it's still uphill. Okay, that's symmetry about the origin. And that is true for odd functions, not just odd degree, but truly odd. Okay? So what we're going to do is we're just going to do a couple of graphs, determine if they're even or odd, and then even degree or odd degree. Okay, the degree is the easiest because you can literally, for a lot of these, just kind of look at it. So x squared is squared even or odd? Even, so put even degree. How do I know? Because the biggest power, the squared, is an even number. Okay, what about the second one? Even degree. Okay, for absolute value, let's leave that one. Well, do you remember the shape of an absolute value graph?
Yeah.
It's a V. Do both ends go the same way or opposite ways?
Same.
Same way, that makes it even. Now, when I say the same, I'm talking about they both point up. So they do go apart because it's a V, but they're both up. So that's even degree. Okay, then for the next one, what's your highest power? X to the what? Third, that's what type of number? Odd degree. And you only really care about the biggest one. So if this was like an x3 minus an x2, you would still classify it as odd because the biggest one is a 3, which is odd. Okay, then for square root, okay, that's going to be neither. Okay, because a half, that's not an even number, and it's also not an odd number. Okay, so let's put neither even or odd degree. Okay. All right. Now, let's go back through the graphs and determine if they're purely even or purely odd. So you're going to have to know what the graphs look like for these, but you can have a calculator do it in Desmos for your homework if you don't know. Okay, for this one, what shape is an x squared graph? U. How does it open if it's got a negative in the front?
That.
If it's a -3 on the outside, it'd go down. So go down 3. Draw your U upside down. Now, we already know it's even degree because both ends point down. But remember, it's only truly even if the y-axis cuts it in half. Does the y-axis perfectly cut it in half? Yes. then this is both even degree and it's even. Okay, let's do the next one. X minus 3 is squared. So it's still a u, but which way is the minus 3 going to move the u? To the right. So go 1, 2, 3. Draw your squared graph. We already know it's even degree because both ends point up. But for it to be truly even, the y-axis has to perfectly cut the graph in half. Does that happen here? No. So I'm going to draw in my y-axis. I see that the sides don't match. So this is not an even function. It's even degree, but it's not purely even. Okay, next one. We have absolute value x minus 2. We already said that's a v. How does the minus 2 shift it? Down 2. So kind of do your best here with the v that we already drew. Just make it like down 2. We already know it's even degree because the ends both point up. How do I tell if it's truly even? What has to cut it in half? The y-axis does it.
Yeah.
Then this one is also even. And remember the difference. Even degree is what the ends are doing. Purely even means y-axis cuts it in half. Okay, next one. X cubed minus x. Okay, this one will actually have to graph. So let me just pull up Desmos real quick. Okay, x cubed minus x looks like this. Okay, sketch that on your paper. Okay, so it's still a squiggle, but it's going to go a little bit up and then a little bit down, but it's still mostly doing the same shape. So let me put mine back up here. Okay, so when I draw my little squiggle here, it's going to go a little bit up, a little bit down. Now, my ends are opposite, so that tells me it's odd degree. But for it to be truly odd, if I put my finger on the origin and I spin my paper upside down, it should look exactly the same. So put your finger here, spin it. Notice my squiggle's uphill. When I spin it, is it still uphill?
Yes.
Yes, then it's truly odd. So we'll put and odd. Okay, but remember, all functions don't count as even or odd. Think about the square root function. If you remember, that's the hook shape. Okay, so if I were to draw that here, plus 3 shifts it up 3. There's your hook. Okay, and why can I not tell if that's even or odd? Because it doesn't even have an end going the other way. Okay, so this would count as neither one. And if it's not even or odd degree, then it can't be purely even or odd either. Does that kind of make sense? Okay. All right, then you're good. So go ahead and pull out your Chromebooks. I'm gonna have to unlock your Delta map. So give me 1 sec to do that. And your homework should be pretty quick. You're just testing over or doing problems on the 3 things. Yes, ma'am. Okay, that's fine. Yeah.